The secrets of the great dying mass extinction revealed. Imagine a time 252 million years ago when Earth's biodiversity faced its most severe challenge yet, a mass extinction event, commonly known as the Great Dying. This cataclysm erased about 90% of the planet's life forms. But what followed this extinction was a baffling enigma. The world became lethally hot and remained so for a staggering 5 million years. Recently, an international team of researchers has uncovered a crucial piece of the puzzle using an extensive collection of fossils. Their study, published in Nature Communications, suggests that tropical forests played a pivotal role in this ancient climatic upheaval. The implications of their findings are profound, offering both insight into Earth's past and a stark warning for our planet's future as human activity drives global warming. The Great Dying was not just another extinction. It was the most severe among the 5 significant extinction events in Earth's history and marked the conclusion of the Permian geological period. The mass extinction has largely been ascribed to intense volcanic activity in the Siberian Traps, which emitted vast quantities of carbon and other greenhouse gases, leading to severe global warming. This massive release of gases disrupted ecosystems, causing widespread marine and terrestrial life to perish, while the oceans became increasingly acidic. However, what remains elusive is the reason behind extreme heat and the prolonged super greenhouse effect that persisted even after the volcanic activity stopped. The scale of warming during this era surpassed any other known event, explained Zhan Chu, one of the study's authors and a research fellow at the University of Leeds School of Earth and Environment. Some hypotheses attribute this enduring warmth to the oceans. Perhaps the extreme heat led to the destruction of carbon-absorbing plankton or altered the ocean's chemistry, reducing its carbon storage capacity. Yet researchers from the University of Leeds and the China University of Geosciences believe that the answer lies in a critical climate tipping point. The collapse of tropical forests, the Great Dying, stands out because it is the only extinction event characterized by the widespread demise of plant life, noted Benjamin Mills, a professor specializing in Earth system evolution at the University of Leeds. To validate their theory, the team utilized an impressive archive of fossil data from China, collected over decades by 3 generations of geologists. By examining these fossils and rock formations, they pieced together a picture of the planet's climate conditions during different phases of the extinction event. No one has ever created maps like these before, Mills explained to CNN, emphasizing the uniqueness of their approach. Their findings bolster the hypothesis that the decline in vegetation during this mass extinction significantly compromised the planet's capacity to sequester carbon, causing elevated levels of carbon dioxide to linger in the atmosphere. Forests play a crucial role in regulating our climate. They absorb and store carbon while aiding in silicate weathering, a natural process that helps remove carbon from the atmosphere. Tree and plant roots break down rocks, enabling rainwater and air to interact with them, facilitating carbon capture. If these forests collapse, the carbon cycle is disrupted, contributing to the continued presence of high CO2 levels in the atmosphere. Michael Benton, a paleontology professor at the University of Bristol, who didn't participate in the research, emphasized that the absence of forests profoundly affects the oxygen-carbon cycles and hinders carbon burial, causing CO2 levels to remain elevated. This research underscores a key point. The loss of forests can lead to irreversible ecological changes on timescales that matter to our planet. While global efforts aim to control carbon emission, this research suggests that reaching a critical threshold could make recovery challenging. The key takeaway: this study warns us about a potential future scenario. If rapid global warming leads to the collapse of tropical rainforests, we may reach a tipping point beyond which Earth can't cool down, even if we stop emitting greenhouse gases altogether. This scenario is a real concern for scientists. There's a glimmer of hope. The rainforests of today might be more resilient to extreme temperatures than those that existed during the prior extinction. This is an exciting avenue for scientific research. Nonetheless, this study serves as a crucial alert. There's a tipping point, Mills warns. If we push the tropical rainforest beyond our thermal tolerance, the historical record shows us the dire consequences, and they're extremely bad. What do you think about the future of our rainforests? Could they withstand extreme conditions better than those before the Permian extinction? Share your thoughts and let's discuss.